All right, let's take a look at area of circles and sectors. So we know that the formula for area of a circle is area equals pi r squared, and we can look at this diagram to get an idea of where that formula comes from. If we take a circle and we divide it into congruent sections and then spread the sections out to form a parallelogram. It's not going to be a perfect parallelogram, but if our sections are very small, we can get very, very close to a parallelogram when we line out the different sections, as you can see on the diagram on the right. And we know that the distance around a circle, circumference, is equal to 2 pi r. So if we look at the parallelogram, the way that those sections would be arranged, the base of the parallelogram is going to be equal to half of the circumference. And that would be equal to half of 2 pi r, which would just be pi r. And the height of that parallelogram is going to be equal to the radius of the circle. So if we take the formula for the area of a parallelogram, which is base times height, and we substitute in those values, pi r for base and r for height, we multiply them together, we get pi r squared. That's where we get our area of a circle formula. So looking at number 1, we want to substitute into our formula area equals pi r squared. Go ahead and write that first. We're going to substitute in a radius of 8 5/10 inches and then calculate what the area would be. All right, so we're going to follow order of operations and square 8.5 first, and we get 72 and 25 hundredths pi inches squared. Be sure when you are finding area that your units match and you have units that are squared. And that's the exact answer. If we wanted a decimal approximation, we can use 3.14 for pi and come up with a decimal approximation. For part B, it's asking us to find the diameter of a circle when the area is 153 and 94 hundredths feet squared. So we still want to start out by writing our formula, area equals pi r squared, and then substitute in what we know. So in this case, we're given the area, so we substitute that in. And that's going to be equal to pi r squared. And then let's go ahead and isolate r squared. So divide both sides by the decimal approximation of pi, 3.14. And now we need to take the square root of both sides. We find that r is approximately 7 feet. And so if we're asked to find the diameter, we need to double that. 7 plus 7 is going to be 14 feet. So let's look at using the formula for population density. So when we're trying to find population density, it's helpful for usually government, but can be for different things. And we're going to look at the population density being equal to the number of people divided by the area of land. So usually it's given in square miles, but it could be any unit. Let's look at example 2. We want to solve the population density problem. And about 124,000 people live in a 2-mile radius of the city's post office. Find the population density in people per square mile. So we know the population density is going to be equal to the number of people, which was given, and we need to divide that by the area of land. So we are given 2-mile radius, so we know that we're talking about a circle, and we're going to have to find the area of that circle, which is going to be equal to pi r squared. This problem, simple, we can square 2, get 4, multiply that times pi. So we're going to substitute in population density is going to be equal to the number of people divided by 4 pi. We can just simplify this, and we can use our decimal approximation to come up with the number of people per square mile. Okay. The next problem, a region with 10-mile radius has a population density of 869 people per square mile. Given the number of people, we want to find the number of people living in the region. So we're given the population density this time, and we're also given the 10-mile radius. So we have two pieces of information, and we're going to find the third. So go ahead and start setting up what we know into our formula. Went ahead and calculated the area for that circle with 10-mile radius to be 100 pi. 10 squared is 100 times pi. And now we're going to solve for p. So we need to multiply both sides of the equation by 100 pi, or however you like to think about it, cross multiply. We need to solve for p. So we end up with 86,900 pi, which is approximately 273,004 and 4/10 people. So now we're going to look at finding the area of a sector, and it's going to be similar to finding the arc length. When you just have part of the circumference that you are looking at, you're going to look at which portion you have and create a ratio, and this is going to be similar. So the sector of a circle is the region bound by two radii of the circle and their intercepted arc. So you can see in the diagram below that sector APB is bounded by the radius AP and the radius BP, and then the arc AB that's intercepted. So the ratio of the area of the sector of a circle to the area of the whole circle is equal to the ratio of the measure of the intercepted arc to 360 degrees. This is really just saying whatever fraction you have of the arc of the circle, then you have that same ratio, that same fraction to the area of the circle. So we have an example of how we would set up the area of a sector in that problem, and we would just take the area of that sector divided by total area, pi r squared, and that would be equal to the measure of arc AB divided by 360 degrees. Or if we want to just isolate the area of sector APB, then we could multiply both sides of the equation by pi r squared. That's how we get the second formula. So let's look at example 3. We're asked to find the area of both the blue sector and the red sector. So I'm just going to start with a smaller sector first, and we can see that that sector is PSQ, and we can see that it's 135 degrees, and we can set up our equation. So we're going to take the arc measure of PQ, which is 135 degrees, and divide that by 360 degrees, and that's going to be equal to the area of the sector divided by pi r squared. But in this case, the radius is 15, so we need to substitute in pi r squared as 15 times 15, 225 pi. So I've written this in the format of the second equation, and we have our 225 pi that's being multiplied by 135 over 360. We can go ahead and reduce the 135 and 360 to 3/8. They both have a common factor of 45. That's just going to make the problem a little simpler. And we end up with 675 pi divided by 8, and we're working we should have centimeters here. So now if we want to find the area of the blue sector, we saw that the 135-degree angle was 3/8 of the circle, so what's remaining is going to be 5/8 because together they make up the entire circle. So if we want to find the area of the blue, we can just go ahead and take the reduced fraction of 5/8 and multiply that times the area of the circle. The area of the circle doesn't change. We still have 225 pi, 15 times 15 pi, and we can end up reducing this to 1,125 divided by 8 pi, and we want to have centimeters squared again. All right, let's look at a couple more examples. Number 4, you're given the area of the sector, and you still, want to use the formula from the previous notes, and we're going to set up using the information we know. We're trying to find the area of the entire circle, circle S in this case. So we know the area of the sector is going to be equal to 135 divided by 360, which we already found that that's equal to 3/8. So why don't we just use 3/8 r squared pi. So now we want to simplify our equation. Our goal is to solve for r. Multiply both sides by 8, and we isolate our variable r squared. And we're trying to find the area of a circle, which is equal to pi r squared. So actually, we don't need to take the square root of both sides if we don't want to, because we're just going to end up squaring the value anyway. So let's just keep r squared as this value, or you could also have it in radian form. So write the formula, area equals pi r squared, and then let's substitute in the values. So we have our r squared is 128 divided by pi, and we're multiplying that times pi, so that's going to be helpful because it will just cancel out, and we have our units are going to be feet squared, so we have 128 feet squared. That's the area of circle S. Go ahead and start example 5 on your own, similar to the one on the previous page. Set it up, use your formula, and we'll check in just a minute. Remember that you need to find the area of the circle. Area is equal to pi r squared, so you want to square your radius. 4 times 4 is 16, multiply that times pi. 16 pi is going to be the area of that entire circle. So let's write that out. We have our sector is 140 degrees. We want to divide that by total, 360 degrees. Multiply that times 16 pi. Do some simplifying to make this problem a little easier. And then when we're done multiplying, we have 56 pi divided by 9 centimeters squared. Careful on your units. 5b is very similar to example 4, where we're trying to find the area of circle Y, and we're given the area of the sector, and we're given the degrees of that sector. So we want to set up our equation using what we know. The sector has 25 degrees. We need to divide that by 360 and multiply by pi r squared, and that's going to be equal to the area of the sector, which is 4 1/10. So now our goal is to isolate r squared. Can first reduce and then multiply both sides of the equation by 72. And then we're going to need to divide by 5 pi. Once we've isolated r squared, we have what we need to use the area of a circle formula. So area equals pi r squared. So write that formula and then substitute in this value for r squared. You can see once again we have a radius squared value that's being divided by pi, and then our formula calls for multiplying r squared times pi, so the pi is going to cancel out. So we're going to just have an area that's equal to approximately 59 4/100 feet squared. For example 6, we're asked to find the area of the heart-shaped garden to the nearest square meter. So we want to look at this diagram and notice that we have a square and we have two semicircles, and we know that total area is equal to partial areas added together, the sum of all the partial areas. So we can separate this problem into finding the area of the square and finding the area of the circle. Two semicircles equals one circle, full circle, and then adding those areas together. Go ahead and get started on that. Finding the area of the square, just multiplying side times side, we get 64 meters squared. That's the simple one. And now we can find the area of the two semicircles, which is equal to one circle. Area of a circle equals pi r squared. We're not given the radius, but we are given the diameter of the circle, which is 8 meters. So we will need to divide the diameter by 2 and have a radius of 4 meters. Use that value. So 4 squared pi, which is 16 pi meters squared. We need to add these two together and get our total area. Great job.